Rishi.
Hey Jeff KU, this is Nat.
Morning, Matt.
Morning, Max. Shall we start?
It shows that you're sharing currently. So just change slides.
Oh, I am sharing that, yes, for sure.
Oh, that's what we're trying
I
to do.
thought you were asking me to share screen.
Nope, just slides.
Let's start.
Yes, let us start.
Morning, folks. Welcome to IDR. This is IDR116. If you are not looking to attend IDR, then this is the wrong place. With that, let's get started. Here is the note well. This is a good reminder for all of you in the room, as well as folks who have joined remotely. Please read the rules out here. They read very clearly on all the BCPs that go with it. Some meeting tips. Please make sure that you join Meet Echo queue if you're looking to come up to mic and speak. And please otherwise turn your audio off whenever you can. Here is a pointer to resources for Yokohama IDR. And Jeff.
Okay, working group status. We have completed and have an RFC for the BGP cease notification for BFD that just popped out a second ago. BGP link state extensions for SRv6 is working its way through the queue, as is the LS for the TE info. We've also submitted and are trying to clear our AD reviews for Long Live Graceful Restart. That hopefully will go sometime soonish. SRTE policy is also working its way through, and RPD and wide BGP communities is trying to finish up. I'm one of the holdups there, so I apologize on that piece. We do have a planned working group last call coming up for the SRv6 policy for the traffic specs. And we'll be discussing the BGP model last call as part of the presentations coming up. Slide. So adoptions, we have adopted the no target extended community. We've also adopted the IPVPN prefix ORF. The RT derived community from Jeffrey Jong as well. And flow spec network slicing of TS has also been done. The adoption call is closed for tunnel and caps label stack. Sue may have more information to share with that in a moment, but I think maybe. And SRMPLS ELP, the call is closed, so we haven't actually made the call on it yet. SR Policy NRP has also hit the close time, and basically these next three items are, we did working group adoption calls, and we're still trying to build chair consensus on them. A few of these items, and I think Sue has some details on which ones are sort of at the iffy end of being adopted. We could use, this is a good time that if you have an opinion on these things, please send a note off to the list. We're trying to actually determine should they move forward. We will be doing adoption calls coming up for the SR policy metric. We'll also be discussing the TCP user timeout. This will also be discussed at the upcoming interim on the 24th of April coming up. Please keep that on your calendars. And very similarly for the V4 Island over V6 cores, which will be discussed at the end of the presentation today. So did you have anything to add here? I guess not for Sue. We do have Jen Tan in the. Oh, sorry, Sue. Sue, go ahead.
Draft SAO, IDR, BGP, SRM, PLS, ELP, draft DONG, IDR, SR policy, NRP, draft SES, IDR max prefix, all are short on input. If you have some input, please send it in now or over the weekend. The chairs will decide next week on the consensus call. Thank you.
Okay, thanks, Sue. Next slide, I guess. So lots of list discussion has occurred on the V4 versus V6 only type features. So we're expecting this conversation to continue. Please let's keep this moving forward. IDR, as you can tell, has been very busy the last few months. This includes what do we do about tunnel caps label stacks, especially for things in the lines of multicast scenarios as part of the discussion points. This could use more scrutiny from the working group. The version capability got a lot of discussion. We want to see, is this something we want to move forward? And send hold timer basically pulled all the air out of the room for discussion, for good reasons in the most recent weeks. So we'll probably be discussing, does that get adopted? The call is closed and we just simply have to build chair consensus. And again, this is also another topic that we'll be discussing as part of the interim. So please schedule time in your schedule for the 24th of April.
And like Jeff said, we have an interim coming up on 24th. Following are the topics that we'll be discussing. We've had an action-packed agenda. We couldn't cover these topics at this IETF, but hopefully in interim, we'll have a lot more discussion. Any questions before we move to agenda slides? Cool. Here is an agenda. I'll request all the presenters to be brief as much as possible and stick to the time because we've got a completely packed agenda. With that, DJ, you're on.
Thanks, Keyur. Hello, folks. As usual, I'll be presenting on behalf of my co-authors and contributors to the BGP card draft. Next slide, please. Oh, can I move? Okay, yeah. Thanks. Yeah, so just a quick background. The BGP card draft was adopted by the working group at the IETF116. It had broad multi-vendor support and 2 interoperable implementations. As part of the adoption call and the ensuing discussion, the chairs had captured a number of items to be addressed. They captured as issues in the GitHub. Some of which are card specific, others are common topics. So we've been working on draft updates to address those issues with guidance from Sue and Keyur. Next, please. I'll go over some of those items just for a quick reference for folks. Roughly in the order of the sections in the draft, a few changes or updates to the terminology and concepts section, mainly to provide better clarity. In general, the definitions are consistent with the the intent-aware routing framework that's described in the related problem statement document that's in Spring Working Group. Next slide, please. Some changes to the next hop resolution section, again, to provide better clarity. We clearly described different aspects. The default resolution based on the route color, the leverage of the color ext com for automated resolution, similar to the automated steering, same design principle. The use of local policy for more customization, and then also clarified the use of regular traditional NPLS paths for resolution of car next hops. Next slide, please. Regarding the LCM extended community, again, we have clarified its usage in the relevant sections to be explicit. Also described the usage and applicability of the LCM EC versus the color extended community in a separate section. Next slide, please. Some changes to the error handling section. We've gotten a good set of good comments from Jeff, and as part of the analysis of those comments, we realized the we had the opportunity to have a more resilient handling of errors in the NLRI, given that we had the NLRI length and the key length in the car NLRI definition. It enables a receiver to use treat as withdraw or discard for a variety of errors instead of more drastic action. So we just clarified that. Also, given that there is the ability to allow newer route types to transparently propagate through an RR, we again clarified its handling and operator control. Next slide, please. Regarding scaling, again, the car NLRI does support packing inherently. We've added some clarification on the applicability to the SRV6 related extensions, both in terms of when the complete SID is signaled or with the transposition model. We also updated with some analysis of the efficiency that the packing provides. Next slide, please. So the draft did have an example of an Anycast IP scenario in terms of a couple of different options for it. We extended that example to support for multiple color domains, as that was one of the questions. We also updated the manageability considerations to explicitly state that only when you have Anycast IP that is shared, by different administrative domains, is the associated color coordination needed. Next slide, please. So a few other changes that we are working on, but it didn't make it to the 0.1 version, but we'll be updating, publishing it shortly as the SRV6 procedures and some security considerations. Next slide, please. So this is just a quick handy reference to the GitHub tracker where the issues are being tracked along with the diffs. So again, there's two sets, one the car specific issues, and in the next slide, the common set of issues. So please, take a look. Next slide, here. And next, just a timely update. We had the EANTech event last week, and so we took the opportunity to do a public interop between Cisco ISXR and Arcus, focusing on the MPLS use case, as that's the that was the initial target, and we have a couple of more items planned for near future. Next slide. Right, so this is the last slide. Just in terms of our action, next steps, some updates that we're working on. We'll publish them, initiate the review discussions as provided guidance by Sue. So we do request help from the working group for reviewing some of these updates and helping with the closure of the issues. Thank you.
Thank you, Dhananjaya. So we do have a few minutes open for questions, and while we're waiting to see if anybody queues up, this is a reminder that for at least this IETF, please wear your mask in the room. Okay, we're not seeing any questions online or in the queue. Thank you for an efficient presentation. So we'll be moving on to the CT half of the presentation. Nets, feel free to go ahead.
Hello. Am I audible?
We can hear you.
Sure. Thanks. So hi, this is Natarajan Venkatraman, and I'll be taking you through the status of the BGP classical transport planes. This was adopted as part of IETF116 as an experimental draft. And there was similar to the description from the car authors, there were similar issues being tracked in the IDR GitHub for the same. And in the last 6 months, we have been addressing all these issues and closing them. And we have also been able to get our hand on a few interrupts. So next slide, please. So the agenda is just to describe the current status and to see what are the next steps that we're trying to progress. So next slide, please. So as of the last week, we have closed, I think maybe a couple of weeks back, we've closed all the issues that have been raised as part of CT and as part of work group. That is the first bullet item. So if you want to take a look at the overall draft for your reading, to be at the link provided in the first bullet item. The second bullet item is the one for the email discussions that we have raised in IDEA. You can quickly click on these search strings to land on the issues that we have opened the emails for. And these issues have been logged in mid-February. Just give me a second. Yeah. Mid-February, and we're awaiting feedback, and we'd be happy to help as the work group initiates reviews, and we'll be helping people to understand it and close these issues. So feel free to look through these things and the issues. So broadly, it's mainly about route visibility, the usage of RD, the SRv6 procedures, SRMPLS procedures. Then we have migration scenarios and deployment consideration, usage of 8277 NLRA and its benefits, as well as some of the update packing tests we have been able to do. And with respect to scaling, we're able to, we've added sections to achieve the corresponding section where it is addressed. And other than the issues, one of the issues that Ivan mentioned here was the PEC link intent signaling for the PEC side BGP sessions for CT. So how it's done. And the last, which was not part of the issues, is the handling for best effort traffic in BGP CT. So that's a new section we came up and thought we should cover it up. So next slide, please. And as part of the last 2 IETFs, we've been having some interesting time and trying to churn out a few demos. And first one, we are able to implement CT with another vendor, a free router, who is able to do it fully, do a full interop with us. So there are 3 interops that we did. The first one was with free router. This is where free router maps CT traffics to the best effort tunnels. So this is a full control plane interop, but the data plane just sticks it to the best effort. The second one in the hackathon is an interesting experiment where we were able to signal BGP CT using SAFI 128, and we were able to have Cisco able to signal LISIS tunnels based on that, and then the end-to-end traffic, and it was able to capture whatever Cisco was able to signal as part of the CT operating in Juniper in the upstream node. So both the downstream and upstream, the Juniper and Cisco in the middle, were able to signal and establish an end-to-end plan. That is an interesting thing. So the links for these things are present as part of it. And along with this comes, say, a 10-minute videos where you'll be able to see what we did and how the demo was executed. And as part of this hackathon, just a couple of days back, we were able to do the full interop with BGP-CT and the RSVP-CT intent-specific terms. So this is the SRMPLS interop, full interop to preserve the end-to-end service intent. So these three have been done. And moreover, IANTEC will announce the results on April 18th. And we are under terms of NDA so that we won't be able to disclose any of those results now. We will, so those results, you can find it during the interview. So next slide, please. So the next steps for our most important thing is the formal closure of the issues in IDR GitHub. Feel free to communicate with us and we can work together, set up maybe short calls and see if we can close these issues soon. And there is one open item for IANA code point for MPLS OAM. We have so we did have some correction to the text that we needed to do for OAM, and we had corrected and provided, and there is a feedback. And sometime soon they'll be allocating us the MPLS OAM. That we would want to also, once these things are closed, we would actually, in the next upcoming, based on the trend, we'd like to request for RFC formally. So that's all from me.
And we do have a question. Dhananjay, you have the mic.
Hello. Yeah, thanks. Could you please go back to the interop slide, Jeff? Okay. Oh, can you guys hear me?
We can hear you.
Yes,
Okay.
DJ.
Yeah, I just wanted to go to that slide to raise a couple of questions or comments.
Which slide, DJ?
The interop slide. Okay, thanks. So I see that there's a reference to iOS XR in a couple of places. So regarding the first one, since iOS XR does not support BGP-CT, so I would imagine the reference to it in the context of interop is not accurate.
That's why we put it as an experiment. It's not like qualified it as an interop. Yeah.
Okay, so I was referring to the first reference. So perhaps that one, if that's also the same experiment.
No, all of them are interops. So whichever is the experiment is written specifically as experiments. We also thought how we would put these slides. So we specifically discussed on this and put it as an experiment. So do you want us to put it in a different slide, or we can do it? Yeah.
No, in any case, I think iOS XR does not support BGP-CT. So I think we should probably not refer to interop with iOS XR. That's one point. The second, with respect to the experiment, it's a bit confusing what is being sort of stated or implied. I mean, if SAFI 128 is sufficient to actually use on transport hops, then it's not clear why we need a CT SAFI at all. One could deploy SAFI 128. But if we do need to use CT with the additional procedures that the CT draft describes, then it would not be accurate to say one can use SAFI 128 to interop with the nodes that does not support CT. So there's a bit of a contradiction there.
Okay, so in the interest of time, I apologize. We're out of time, Nats. So the slides do actually have a link to the PowerPoints discussing with the scenario. I suggest, Nats, if you could please repoint to that on the list and maybe continue this piece of the conversation there.
Yeah, sure.
Okay.
We are very happy
Thanks,
to
guys.
assist you with this, DJ, and you can first initially look at the video, and then maybe you can we can have a separate discussion offline. How do you say? Works for you?
K10 is going to be our next presenter. Thank you very much, Nats.
Well,
Oh, I'm
K10,
sorry. Sorry, you're correct. Still, you wanted to go for 2 minutes.
Yes, 2 minutes. Just to plea, folks, both the CAR and the CT teams have worked really hard to try to address the issues that were listed on the IDR list. Please, I'm going to have calls to try to close this issue in order to have a better last call. I really ask you to take a look at the email I sent, take a look at CT's existing calls. DJ and others are going to send out calls within a couple weeks, and we'll be dealing with these calls in April and May so that we can head toward working group last call. So I'd appreciate your help so that we can have a good conclusion to these critical drafts. Thank you.
Thank you, Sue.
Hi, good morning. I'm K10 SR, presenting on behalf of my co-authors. These two drafts, go on to the next slide, please. So these are 00 revs, but they are not new working group documents. They have been around since 2014 as a working group document, and it was the TLSP distribution. This draft was covering advertisement of different types of T policies, LSPs via BGPLS. So what we have done is that we have split this into two separate working group documents. One of them is focusing purely on SR policy advertisement, and the other has MPLS-T LSPs, including RSVPT tunnels, local LSP cross connects, and similar forms. Next slide, please. So why we had to do this split is because we were polling the working group for implementations, feedback, and all. What we got response was that there is no implementation planned or existing for other than SR policies, and we need two implementations to progress towards publication. So we thought that splitting in this manner would help us do that. Next, please. So now going into the two documents that we have. First, on the SR policy part. Next slide, please. So here there is a good progress from the spec, but also more importantly from implementation perspective. So I'm aware of a few implementations that are either already available, exist, or are in progress. We are still getting some feedback from this, so we would like to keep working on that to get those inputs back into the draft. And there are some pending code points which we still need to allocate, so we'll get that done. Probably sometime this calendar year, we hope that we'll be ready, and we'll start sharing or putting across the implementation report to get feedback. So the request to the working group is to review closely and come back or share their feedback. And once the implementation report request is out, please help fulfill that, fill that info. Next slide, please. So this is the TLSP path part, the other draft. And next slide. So this one, we really need to know that there is any interest or plans for implementation, and if so, please share your feedback or either on the working group mailer or with the authors. We also need to allocate some code points, but I guess it makes sense to do that when there are concrete implementation plans. So until then, maybe we'll just keep it the way it is right now. And that was all. So any feedback now or probably on the mailer is better. Okay.
Thank you.
Thanks.
Any questions for K10? Okay, our next presentation. This will be Mahesh and I.
All right, so this is a joint presentation between Jeff and I. I'll go first with a few status updates, and Jeff will come back to talk about some of the slides, maybe, and I'll close off the presentation. Next slide, please. So this is version 16 of the draft. We did do a name change just to reflect the fact that the model is no longer just applicable to the service provider network. Next slide. Couple of changes. We did add 2 modules. Both of them are IANA modules, and note to the authors that the IANA might want to ask about how these models are going to be maintained, whether you need somebody like an expert reviewer to make changes. So something as a note. The IANA BGP notification module was added to better capture the operational state of the model. It includes notification messages, error codes, and subcodes. The BGP community types is, again, both being maintained as IANA simply for upgradability and maintainability. So all the community types definition has been moved into that module. We did also add 1 submodule for the BGP capabilities and separated it out as a better way to modularize the model. Next slide. So here is, Jeff will come back and talk about the AS path, but you will see a proposal of what we would want in the appendix of the draft. There's a detailed discussion, but Jeff will highlight some of that. The idea is, of course, to come up with the regex for AS path, and we'll talk about that in the following slides. We did add IPv6 extended community support in the model, and also more neighbor counters. Add path was something that was missing at the global AFI-SAFI level, so we did go ahead and correct that. Next slide. TTL security logically belongs under transport, so we moved it there. We did rationalize the prefix limit feature. Initially, as it was threshold. If the threshold exceeded, we would tear down the session, to now where if it exceeds, there is an option to either tear down or log the fact that it has been exceeded. Next slide. Things that have been moved out of the model include the configuration for AO and MD5. They now rightfully belong in the TCP YANG model. And all that BGP does is identify a keychain that should be used along with TCP AO and MD5. Next slide. And Jeff is where you come in.
Thanks, Mahesh. So there are a couple of very large problems that are not really cleanly dealt with across picking on the open config model, which has gotten a little bit more traction than the IETF model has. So we're drawing a line in the sand and saying, here's how we'd like to try to solve the problem. So for AS paths, regular expressions, anybody who's worked with BGP for a long time knows that the syntaxes across implementations for doing regular expressions is wildly inconsistent. And this means that trying to come up with an IETF vendor neutral model to allow us to actually deal with these things is a little challenging itself. So what we're looking for is a set of functionality that can be dealt with in a vendor neutral way and can implement from the YANG model to a vendor specific model without too much problem. What we've chosen to do as an attempt at this is we're going to deal with all the things that are problematic about AS paths, specifically the fact that character token based is probably not what we want in most implementations. Most are integer based. POSIX regexes don't deal with this sort of thing. Next slide, please. And segment types aren't dealt with. So we need a way to standardize what the regular expression looks like. We have two flavors of this in the presentation portion of things. There's a format that is abstract in terms of the actual segment types within the model. We don't worry about a canonicalized formatting model so that vendors can display their various grouping tokens as they choose without imposing one on them. But in terms of the regular expressions, we're leveraging RPSL, which actually has been around for a very long time, has support for various toolings across vendors to generate regular expressions, and covers a very common subset of what regexes can do. Next slide, please. So these are examples of regular expressions that you can do in the RPSL style of things. So this is potentially a controversial thing to do, but that said, there's no industry-wide answer for this yet. So this is a place to start the conversation. Those of you who care about modeling and implementations for modeling, please take a look at this section. You will have an opinion. Next slide, please. We have a very similar problem for community regular expressions. These are a little bit more standardized across the various vendors in terms of what they do. The problem is, some of the functionality is inconsistent. This means that IETF has choices to make. The choice that we decided to put into the draft is that we're going to choose a limited subset of POSIX.2. You will recognize this from standard egrep, if you're a Unix person. And this means that if you know how to use egrep, you probably know what these things potentially look like. What we are doing is excluding specific sub-features in this POSIX format. Next slide, please. So examples of things that we're excluding are character classes, collating symbols, equivalence classes, and far more important for some of your implementations, backrefs, which are an extremely powerful feature when you're dealing with regular expressions and communities. That said, we're looking at this as being the baseline support. There's options for implementations that have better support, which will imply some sort of capability advertisement in the Yang module to tell you what you can do, but we have to tell you what the baseline can be. In summary, again, these two items here, they are controversial. You are highly requested to review these because you will care about the outcomes. Thank you.
Next slide. All right, so we are, of course, tracking all these issues at the GitHub location on the page. Major issues, we already talked about ASPath and community expression, which is not on the slide. One minor key item on the top of the list of neighbors that needs to be fixed, and then the minor issue of punctuation cleanup that is still remaining. Almost everything else is an enhancement at this point, and we have deemed that it's something we want to tackle as a biz or in a new draft. Final slide. All right, so I believe we are there. I say 99%, but then it's been 8 years and going. So, V17 is, so we're still hoping it'll be the final version. From a chair ask perspective, I believe we will need to identify a shepherd since all co-authors are also chairs. Yang Doctors review, we have had two already. I don't know if a third would be needed since the amount of changes that have gone are significant. I don't know about Obster review for this model, but definitely a routing directorate review would be needed. Any questions?
Thank you, Mahesh and Jeff. We've already had G as a shepherd for this document. So G will be writing the shepherd report.
Any final questions? Anything online? Okay. IFit. Bruno.
Hello, this is a short update on this working group draft, which is a BGP extension for advertising in situ flow information telemetry capabilities. Next, please. So what we have done so far, we have presented the draft at IETF 109, 110, 114, and we got good feedback. We'd like to thank the following reviewers. And we believe all comments have been addressed. So if not, please come back to us. Relatively independent of this draft, we used to use the BGP next up capability draft, working group draft in IDR. And that draft has been merged with IDR entropy label. And so we need to sync the change. And now we're using the draft IDR entropy label capability. Next slide, please. So in terms of outcome, we use the BGP router capability attribute, or RCA attribute for short. As a reminder, it is an optional transitive BGP attribute, type code 39. And the IFit capability itself is encoded as a capability of RCA attribute. IFit capabilities are modeled as a set of flags. So if the flags is set, that indicates that the router is capable of processing that IFit method. And the set of flags is encoded as a 32-bit mask. I believe current version of the draft has a fixed length, so it's only 32 bits forever. So the feedback from IFit is that it should be more than enough. But please comment if you believe we need more or we need extensibility. Next slide, please. So that's all from me. Comments and questions are more than welcome, and we'll revise the document accordingly. Any question? Susan?
Sue, you have the mic.
I'm not hearing you, Susan.
Okay, let's see if the mic is here.
Yes,
okay.
Thank you.
Not just one comment, not directly on this draft, but on the draft you're referencing. The IETF IDR SR Policy IFit based draft is one of the requirements. That's sitting, holding, waiting for implementation. So if you have know of implementations as you're working on this, it would be helpful if you would send that information to me so we can start one of the base drafts working group last call, because you have 3 of these drafts that you'll need before you go to working group last call for this draft. So please, if you can help me with that, I appreciate it. Thanks. Bye-bye.
Okay, I don't have the information right now, but I will come back to you.
Thank you. Thank you, Bruno. So while we're waiting for the next speaker to stand up, speaking of standing up, Andrew, would you please stand up and let people meet you? This is Andrew. He is our new AD for IDR and also the chair AD for BESS as well. So many of the BGP things will now be under a single hat. Alvaro, if I think you're still in the room as well, please stand up and be recognized for all of the work that you've done over the years for us. Thank you very much.
Thank you, Jeff. Thank you very much. And thanks to everyone. You know that the work is done by all of you, right? I pushed the buttons, and now Andrew's going to push the buttons. But I'm happy to see not only all the people in this room, all the very important work that IDR has done and keeps on doing. This to me, and I tell this to everyone, BGP is the most important protocol on the internet, and IDR is the most important working group in the IETF. And I'll tell the quick people, yes. And not only that, but it's the biggest working group in the IETF. It's a working group that creates the most documents, that processes the most documents. And I'm sure Andrew will be very grateful for all of your reviews of all the documents that are in the state here, especially the very long BGP model. Yes, thank you so much.
I also just wanted to send a special thank you to Alvaro for leaving me a relatively short queue. Thank you, Alvaro. It's been a pleasure from my side working with you, and you've left the handover in good state with IDR, and it's much appreciated. And I look forward to working with all of you. And yes, the reviews, particularly on that Yang document, will be hugely appreciated.
I will say thank you, Alvaro, and welcome, Andrew.
Please go ahead.
Okay, hello everyone. This is Ka from Huawei. Today my topic is the BGP SR policy extension for template. Next slide, please. And as we know, BGP can be used to propagate the SR policy candidate path to the head and node in the network. And the SR policy encoding structure is like this. In this structure, basic attributes of the candidate path are defined in this protocol. Next slide, please. But in application, the head node and routers may need to apply many features to the candidate path, and some features are only meaningful to the head and nodes and no need to know by the controller or by the protocol. For example, if the candidate path need to create a seamless BFD session for one 4-segment list, then we just need to configure the seamless BFD in the device and give the state of the state feedback to the controller. So I think we should define a template that can show this information from BGP. And also, there may be many features like this, and features may change frequently. So we can use template to avoid the BGP protocol changing too frequently. And also on the device, if different SR policies may use the same features, and then they can use the same template, thus can simplify configuration and improve maintainability. Next slide, please. So we define a template that is a group of features for SR policy candidate paths, and we use an identifier which is meaningful to the head and node of SR policy. The identifier is configured by user or controller and is only unique on the head node and valid on the head node locally. And there are 3 steps to process the template. First, we can configure 2. For example, we can configure 2 different templates. One is for the primary path, and the other is for the secondary path. And the BFD minimum transport interval is different for these 2 paths. And then the controller can get the template information and calculate the candidate path, and then choose the template they want to use. And after this, the controller will download the candidate path and with the information of template ID in it. And the 3rd step, when the head node of SR policy receives this message, and it can find the template by using the template ID, and then set up the path with attribute that is defined in the template. Next slide, please. And so we define a template ID sub-TLV in the tunnel encapsulation attributes, and the format is like this. And now the type for template IDs to be defined, and the length is a fixed value of 6, and the flags are not defined at this stage. And then the template ID value, it is a 4-octet value. Next slide, please. And there are some operation considerations. First, the template ID is chosen by the controller and initialized by the controller. And then when BGP advertise an SR policy, different candidate paths of the same SR policy may have different template IDs, or may use the same template ID depending on the attributes required by the candidate path of the SR policy. And when receiver get the information, SR policy is only to be processed on the SR policy head end and is being incorporated in an SR policy module. The SR policy module find the local configure template by template ID and get all the attributes that is configured in the template, and then process the candidate path with these attributes. For example, if the template configure seamless BFD, then the SRPM can create a SBFD session for each segment in the candidate path. If there is no template found, the SRPM ignore the template ID and use the candidate path as there is no template. Next slide, please. And there are some questions. First, it is about the template ID. Now the template ID is a local identifier just to use on the head end of the SR policy, and it's a local configured identifier needs to be unique on the head end device, and we need no further process to coordinate the template ID between multiple routers. And also, the SR policy is only to be processed on the SR policy head end. Reflector just need to reflect the router of the SR policy. No need to process it. To make this possible, an attribute needs to be attached to the advertisement that enables a BGP speaker to determine whether it is intended to be a head end for the advertised policy. This is done by attaching one or more root target extended communities to the advertised, and this procession is defined in draft IETF IDR segment routing TE policy, and the template ID does not add any extra process in this case. And also, there is a similar object that is defined in PSAP, that is the association object, but BGP does not define this. So I define this template to do the same thing. Next slide, please. And welcome questions and comments.
Thank you, Ka. I have a question, but first, this is a reminder for the people in the room that for at least this IETF, please wear your mask. Ka, my question, if you go back to slide 7, please. Actually, sorry, this is more of a comment. Okay, we're back to slide 7.
Oh, sorry for that.
So you point out very well in your draft and your presentation here that the template ID numbers are not coordinated. So you're very clear about this. The thing I would like to point out, less to you and more for the working group, is that this is a very important observation. This is a very local mechanism, as people are wanting to potentially make use of the information in these path attributes, maybe for families that are not SRTE policy, that this becomes a potential tripping point. If you use this elsewhere, this becomes potentially problematic and the global issue may need to be solved. So if you have opinions about this, please talk to the authors and maybe discuss with them about working out with a coordinated global mechanism.
Oh, okay, thank you.
Sorry, there's also a question for Shraddha. Shraddha, we do not hear you. Okay, Shraddha, you seem to be having microphone problems. So if you could take it to chat and or mailing list, we'll go from there. Thank you, Ka, for the presentation. Meng Xiao? Do we have a presenter for this?
Can you hear me?
Yes. We can hear you, yes.
Oh, thank you. Hello, everyone. This is Meng Xiao from New HCC Technologies. I will give this presentation on behalf of my co-authors. Our draft is about BGP SR policy extensions for segment list identifier. Next slide, please. The BGP SR policy draft specifies a mechanism by using BGP to distribute SR policy to head-end nodes, but there is no identifier for segment list in a BGP SR policy, and it may cause inconvenience. The first example is that head-end node collect and report traffic forwarding statistic per segment list to the controller. Because there is no identifier for segment list, a current solution is that the head-end reports the whole segment list along with the statistic data, and the controller has to compare the seed one by one to identify the segment list. The second example is that SR policy is distributed
Meng Xiao, we've lost your audio.
Oh, we lost that.
Sorry. I'll continue.
We can hear you again.
The second example is that BGP SR policy is distributed by BGP, and the configuration per segment list is distributed by netconf. In this case, the controller needs to distribute the whole segment list along with configuration, and the head-end has to compare the seed one by one. So a simple identifier for segment list can be helpful. Next slide, please. In PCEP and YANG, there are already things like segment list identifier. I can't see the slide.
We're having technical difficulties. 1 second, please. Sorry, which slide should we be on, please? Meng Xiao, can you hear us?
Sorry, I get a bad network.
Bad network here too. What slide should we actually be on?
It should be page 3.
I think
We are
this is the
currently on
wrong
slide 3.
person.
the wrong slides there.
I think this is the wrong presentation.
Yes.
Thank you, Randy. Sorry, we're juggling slides up here.
Oh, I can see the slide. Hmm?
Okay, why don't you look for it as well?
Yeah, in the segment list identifier. Go up. One more. One. That's the one. Segment list identifier. Yep. You on the right slide?
This is the right presentation.
Yes. Now you lost.
And now I've lost the communication. Let me restart my Echo.
Beautiful. I've completely lost network connectivity. Does anyone have network connectivity? Maybe I have to go there. Or maybe that's
Segment list.
The legacy network seems to be stable for me.
Okay, Weng Xiao, I think we restored slides. Can you see slide 3?
Yes, I can see.
Please continue.
Oh, thank you. In PCP and YANG, there are already things like segment list identifier. In PCP, a segment list is identified by path ID, which is a 4-octet identifier. In YANG model, a segment list is keyed by its name, which is a string. Next slide, please. Our draft defines the extensions to BGP SR policy to specify the identifier of segment list. It could be a 4-octet number carried in segment list ID subtier V, or a name carried in segment list name subtier V. Both the two forms are provided to achieve better flexibility. Next slide, please. This slide shows the format of new defined segment list ID subtier V and segment list name subtier V. Next slide, please. We gave a presentation about this draft on the 114 spring meeting, and it is presented here. We want to seek for the feedback from both the spring and IDR working groups. Any questions or comments are welcomed. Thank you.
Thank you for presentation. Are there any questions in the room or online? We do have questions. Aijun.
Yeah, Aijun from China Telecom. We know there is already the pass ID definition for the SR policy. So we want to know what's the difference and what's the usage for the segment list identifier. Can the pass ID be used for the similar proposal?
Oh, thank you. This is a good question. I think the segment list identifier in our draft and the path segment are two different things. The identifier here is similar with the path ID in PCEP and the name in YANG model, while path segment is usually used for performance measurement and path correlation. One of my co-author is also the
Oops, we lost him.
Mengxiao, we've lost you again.
hello. Sorry.
We can hear you again.
One of my co-author is also the author of segment paths. Author of path segment draft. And we have discussed this issue before, and we think there is no contradiction.
Okay, thank you for your answer. Lu Yao, do you have a quick question?
ID in BGP SR policy has been defined in another draft of ours, but for different purpose originally. You may want to check that. I will send the name
Oh,
in
thank
the
you.
chat.
I will read that.
Okay, there are no further questions. Thank you for the presentation.
I'll have to pause the screen share. There, up there, yes. Thank you.
Hi, I'm Yao Liu from CT. I'm the next presenter. This draft is about advertising seed algorithm information in BGP. Next slide, please. As specified in draft IDR segment routing T policy, SR algorithm can be optionally specified in segment subtier Vs for SRM pairs prefix, SRv6 prefix, and SRv6 adjacency. And the draft LSR algorithm-related adjacency set complements that the algorithm can be also included as part of an adjacency set advertisement for SRM-PRS in scenarios where multiple algorithms share the same link source. So in this case, an SRM-PRS policy advertised to the hand end may also contain algorithm-specified adjacency. And this document defines new segment types to provide algorithm information for SRM-PRS adjacency when delivering SR policy. Next slide, please. Four new segment subtier Vs are defined. They are defined taking examples by existing subtier Vs for SRM-PRS adjacency, except that there's an SR algorithm field included. So I'm gonna skip the detailed structure for the new segment subtier Vs. Next slide, please. And we can turn to next slide, slide 5. Okay, and this draft has been presented in RDR working group in IETF 113. And here are the main updates since then. This draft not only focuses on advertisement for SR-MPLS adjacencies with algorithm based on K10's comments. Other irrelevant segment types are deleted, and the name of the new segment subtier Vs are modified to be aligned with existing segment types. And the definition of the fields in the new segment subtier Vs are complemented in the draft. And next, please. And we ask for review and comments and request a working group considering the adoption. That's all. Thank you.
Thank you for the presentation. Is there anybody that would like to ask a question? Okay, there are no questions online or in the room. Thank you for the presentation.
Hi, I'm Wen Yan. My topic is loop provision for routing in table between protocols. The main idea is to extend a new BGP attribute and the main idea is to generate a new router origin size information through the route important protocol and transmit it through a new extended BGP attribute. Next slide, please. Both BGP and IGP has their own anti-loop mechanism, but the route import may cause the loss of the anti-loop attributes of the protocol. So next, I will use example to explain the specific problem. In this networking, we suppose that there have a route in RA, and the RA advertise the route to RB, and the RB advertises the route to RC and RD. In RC, IGP import the BGP routes and advertise the routes to RD with the IGP peer. In RC, in this case, the anti-loop attribute is lost. So in the RD, after the BGP route selection, RD advertises the routes which from RC to RB. And in RB, after route selection, it advertises the routes which from RD to RC. Now in RC, there has a route loop occurs in RC. Next slide, please. So the same problem exists after the protocol swap. Next slide, please. In order to solve the problem above, we propose an extension to BGP attribute. The new BGP attribute is coded route origin size list. It is an optional and a traditional attribute and have one or more attributes. Each one or more subtiers. Each subtier indicate a set that the routes was imported into BGP or IGP routing table for the first time. And when the router received this attribute should use his local size information to compare with the attribute contents to determine whether a loop occurs. Next slide, please. This slide I use the example to explain how it works, and let's use the previous networking. We also, at the same way, we suppose that there have a route in RA. The different is in RC, OSPF import the BGP routes, and OSPF add its local size information 100 to the route. So the OSPF advertise the route with 100 to RD. In RD, BGP import OSPF routes, and also BGP add its local size information 200 to the routes. After the route selection, RD advertise the routes with 100 and 200 to RB, and the RB advertise the route which from RD with 100 and 200 to RC. And in RC, OSPF imports BGP route again, and in this time, OSPF uses its local size information 100 to compare with the attribute contents 100 and 200, and find that a loop occurs. And we can break the loop in here. And in another scenarios, if there have if RC have no other route to select, it will advertise the loop route to RD. And in RD BGP re-imports the OSPF routes and use 200 compare with the attribute, and also can find the loop occurs. So we can also break the loops in RD. Next slide, please. So we'll come more comments and discussion. Thank you.
Okay, Wenyan, this is Fan Gao from Zhongguan Laboratory. I read your draft last night, so I have detailed questions. You record a pair of tuple on the routine redistribution, and the first member for BGP is the VPN ID, and for IGP is the process ID. And there is a situation on the network, maybe multiple or two IGP instances is binding to the same VPN instance. That is permitted on both configuration and the real deployment. So my question is that on this scenario, you will compare the value directly, or you will seek into the VPN instance by the process ID of OSPF and then make the comparison.
Yes, yes. This question just this question BGP use the sorry, IGP use his process ID. We think the process ID is different between the each process. So we can use process ID to identify the a single OSPF process. But this the process ID also can be changed to OSPF's router ID. So my answer is that.
Okay, thank you. I think that is not a real scenario because even the global routing table could be deployed as this. Maybe if it's possible, you can add some description to about this. Thank you.
Oh, thank you.
Next question is from David Lamperter.
Sorry. Historically speaking, this would have been a configuration error. I'm not opposed to trying to improve this, but I think this might be better suited in the routing area working group. Yes, right?
Your question is our documents belong where?
Yeah, I think so I think this needs specific information for each of the protocols that we're trying to do loop avoidance for. For BGP, we may want to include the AS path or something. For OSPF, we may need a process identifier. For SIS, I don't know what it is. So I'm not sure this is maybe a little bit just misplaced in where we're moving this draft.
Yes, this is our first version. In the future, we will expand to the other protocol to the draft. Thank you.
Okay, thank you, David. Next set of questions are mine. First question is, have you presented this to LSR yet? LSR working group? Have you made a presentation of this to, sorry, I will remove my mask. Does this help? Have you presented this to the LSR working group?
No.
Okay, so this may be a potential next step. My next comment is, are you aware of RFC 1354?
Okay.
Okay, so in the chat, you will find a pointer to RFC 1354.
Okay.
This is an idea that has been done before. It is not generally not deployed because redistribution back and forth into the IGP, as you're seeing, causes problems. And mostly the answer is, this hurts, do not do that.
Oh.
And that said, sometimes old ideas are worth re-examining. So my suggestion to you is review the old RFC and perhaps talk to some of the older network operators that were present when these things were new, and see if there is wisdom that they can share for that.
Okay, sorry, I don't know there have a RFC to describe this question, so I can read the RFC outline.
Your methodology is different and solves different scenarios, but perhaps reviewing the old material may provide inspiration.
Yeah, okay.
Okay, that was my question.
Thank you.
No further questions. Thank you. Srihari, you'll be next. Srihari, you have your hand raised. You are not sharing your microphone.
How about now? Can you hear me?
We can hear you now. Thank you.
All right, cool. So, good morning, folks. This is an update on the generic metric extensions for EAGP attribute. It's a draft that's been there for over a year now. And I would like to take an opportunity to welcome additional authors, co-authors on this, and give an update on what we've been doing since the first update. Next slide, please. All right. So what I'm going to talk about here is just to give a recap of the problem statement and solution summary at a high level. Talk about the updates to the draft, especially the deployment use cases and the next steps. Next slide, please. All right. With all the new services and applications driving the different types of traffic that may be routed, satisfying specific constraints, we all know that. And at the same time, the link metric has evolved beyond the traditional IGP cost. You could see in the IGP metric type registry, there's delay, bandwidth, and there may be new administratively assigned metric types that may come up as per the draft that's been floated in the LSR. Next slide, please. Given the intent-based routing interest in the community, the operators are looking at how do we provision end-to-end paths across their networks, which is also multi-dome, multi-AS networks. So in this scenario, given the link metrics beyond IGP cost, as well as multi-AS networks, the AIGP attribute, which is defined in our RFC 7311, can carry only the IGP default cost today. The draft, the RFC defines only one TLV, that's the EIGP TLV, and it specifies IGP cost. It would be really good to have an alignment between the IGP metric types as per the IGP registry and the EIGP metric. That way it can simplify the network operations. Next slide, please. So the proposal here is extend the EIGP attribute with a new TLV. We're calling it as generic metric TLV. And this metric TLV will carry the individual metrics as defined in the IGP metric registry with a specific value. That's 8 bytes as defined here in the draft. Next slide, please. Just to expand more on what's defined, what's specified more clearly in the draft, the usage of the generic metric TLV in terms of originator, most of it is relevant as defined in RFC 7311. When we are encoding, when the router is encoding the metric, it gets encoded in the generic metric TLV. And the receiver, again, most of the operations are very similar to what's described in 7311. When the router receives a metric type that matches the metric as defined, as used in the local domain, use the received value and process the way as defined in 7311. And on the other hand, if the metric, the local domain does not match with the metric type received in the route, a normalization of the local cost to the next hop is needed, and either a zero or a non-zero value can be added depending on how the operator wants to do. Next slide, please. In terms of the best path computation process, 7311 defines the decision process, and here are the updates to that. Because the generic metric TLV includes all the IGP metric types, include IGP cost. So if we have a route, so this draft says generic metric TLV can be preferred over the IGP TLV. And given a generic metric TLV has a value of t, for example, when it matches the local domain metric type, find out the cost to reach the next hop and add it to that. That's the new updated metric type in the generic metric TLV. If it doesn't match the local metric type, what's there in the route, then normalization is required. Normalization of the metric to reach the next hop is required before it is added, and then it's used in the best path computation. For routes, let's say we have multiple generic metric types. Just to break the tie, proposing a lower metric type can be used as a preference, but this can possibly be also specified in the policy as an operator. Next slide, please. Some deployment use cases, as operators were interested in this. I'm just sharing the next 2 slides. Here's the topology where we have 4 domains within one operator. Call it a single administration domain. And the 4 domains, each of them have their own IGPs with the different metric types. Here, domain 1 and domain 2 use IGP metric in the domains. And domain 3 and domain 4 use delay metric. And the problem is to find a delay-based end-to-end path from P1 to P2. In such a scenario, the domain 4, which is the domain on the right-hand side, the ASBRs, ASBR 41 or 42, may originate the generic metric TLV, encoding the metric type, the delay metric, and add the value there, and before advertising to the domain 3 or domain 2. And likewise, when domain 1 and domain 2 get the those BGP updates, the BGP routes, it may have to normalize the local cost. The local cost is the IGP metric. So before it updates the AGP attribute, the generic metric TLV, it will normalize the local IGP cost and then propagate it forward. And in the domain 3, which is a delay metric, it is very similar to the 7311 RFC, where the local cost, which is the delay metric, is added to the AGP attribute before it is advertised on. Next slide, please. This is the second use case where some of the customers are trying that in a again similar scenario where I want to be able to have an end-to-end path based on the existing method, which is an IGP cost. But given the deployment, certain domains may have been upgraded to, let's say, Flex Algo using delay metric, and I want to be able to leverage the delay metric within the domain, yet still have end-to-end as IGP cost. In such a scenario, again, the topology is very similar. Domain 1 and domain 2 use IGP metric, and domain 3 and domain 4 use delay metric. In such a scenario, all routers update the generic metric TLV with the IGP cost, because that's the intention, to have an end-to-end IGP cost path. At the intradomain path, within any domain, the intradomain, for reaching the ASBR, the local delay, the local domain metric type will be used. So let's say in domain 3, you may have multiple paths, and choosing which of the paths to reach the ASBR from ASBR 31 to ASBR 32, it may be based on the local the delay metric, which is a local domain. Next slide, please. Requesting work group comments, questions. I believe we can take up for the work group adoption, but any comments would be appreciated.
Okay, thank you, Srihari. So request to the authors, please send your adoption request to the mailing list. We'll continue that there. We have 3 people in the queue. Linda, you're first.
Oh, okay. So this is Linda Dunbar from FutureWay. So I do have questions for the matrix. Like you have those domains. Can you put back to that picture with different domains? Okay, so what if like one of the domains, like domain 4, for example, doesn't run IGP? Maybe it is running the overlay network. And what kind of matrix do you propagate? Do you use new ones, or do you still use IFC 7311?
When say overlay, let's say you take BGP LU, for example, that would, you would pretty much still be using one of the metric types, isn't it? Based on what your fundamentally underlay is going to be propagated. So it will still be one of the IGP metric types, isn't it?
So there won't be any IGP matrix. There will be just delay matrix. Is that what it is? And what if, do you have any other matrix? Like if I want something else, do you have it?
It's just definable. So depending on how different metric types are defined, you could pretty much add the different metric types there. It's a TLV
So
at the
it's
end.
your draft. Okay, so maybe we can talk offline. Maybe in your draft, adding a few more matrix we are thinking of. Like
Sure.
For the domain which doesn't run the IGP. Okay,
Sure.
thank you.
Thank you.
Thank you, Linda. David, you are next.
So in my experience, even if multiple domains are using the same type of metric, they may still have made different decisions on how to implement that metric, and as a result, the matrix may not be interchangeable. Have you considered how to handle this case, or are you assuming that there's some kind of agreement on what the metrics actually really mean?
Within, if I understand your question right, different domains have their own implementations of the metric type. Now, when we need to have an end-to-end path, that's still an intent that needs to be sort of agreed upon as to whether, let's say, you want to have a delay or any other different type of end-to-end. Now, when the route propagates through the various domains, and depending on how it is implemented, you may have to look at how do I add the intra-domain cost so that you're still going to be honoring your end-to-end intent path decision. right? So that translation or normalization is what it's still left to the operator and the domains policy. Did I answer your question, David?
Yeah, thank you.
Okay, thanks.
Okay, Louis Chen from Juniper Networks. Just a quick comment. I suggest you to add the unreachable kind of matrix, or I mean, unusable, right? So that it will not make the same kind of problems actually we see today.
Sure. Thanks, Louis.
Okay, Srihar, there are no further questions. Thanks for the presentation.
Thank you, Jeff.
Good morning. I'm Xin Li from Tsinghua University, and we have co-authors. Next slide, please. Okay, actually, this document is trying to extend, like define an attribute of the BGP. And so that's basically the idea for transition from IPv4 to IPv6. Next slide, please. So background, actually there are IPv6 only networks now, but IPv4, IPv6 coexistence may last long. The IPv4 v6 translation technologies are defined about and used for about 10 years. For example, the Android and the iOS embedded the translation in the system. And actually, the data plan, we have RFCs defined, RFC 7915 and RFC 6252, 6052. Actually, I'm the co-authors of those drafts, and also they are encapsulations. And in the control plane, actually, there are existing RFCs for DNS to try to, okay, the idea, maybe a little bit review. The idea basically defined in RFC 6052 is embed IPv4 address into IPv6 prefix. So if we know the IPv6 prefix, including the length, then we can translate v4 and v6 back and forth. So on the control plane, how to find IPv6 prefix, RFC 7050 is widely used again in Android and iOS is based on DNS. And based on DHCP v6 extension, that's RFC 7598. And recently that's based on RIs, that's RFC 8781. However, we have a missing part, which is if interdomain to send this IPv6 prefix information, which actually we have the proposal here. So make a BGP attribute, new attribute and passing through those IPv6 prefix information. Next slide, please. So actually this work, the first draft is proposed in v6 ops, and that adopted to the working document. This is one of the solutions. The idea is actually there are two autonomous systems running BGP. If both are running IPv6 only, then the current technology, one is put two translators between the borders. So v6 translate to v4 and backwards. In that case, can keep the v4 and v6 BGP attributes. However, we need to simplify that. So just put through the IPv6 packets through the border, but make some BGP attribute extension to carry the BGP information. Maybe people argued, maybe we can do multi-hop BGP or those kind of technology. But remember, we are talking about IPv6, IPv4 translation. So even that's v6 embedded v4, maybe we can use translate back to v4 and using IPv4. However, we can use IPv6 only, and in some translator reach the global IPv4 internet. So the multi-hub BGP or those kind of thing for v4 does not really cover all cases. Next slide, please. So idea is, okay, we will use the same IFit that's IPv6 and the SAFI that's unicast. So, and those kind of things, everything retained, but like, for example, like attribute extension, large community, all those kind of things. So define a new attribute will solve all problems. Next slide, please. So the basic idea is because translate from V6 to V4, actually, the only thing we need is the prefix length. Again, because in some cases, for example, my network, Cernet, IPv4 and IPv6 have different original AS numbers. So how about embed the IPv4 original AS number if it's different from V4? Then actually that's for RPK, those kind of verifications. However, maybe there is a container or TLVs which can contain all the IPv4 attributes and put here. So that's basically the ideas. Next slide, please. And so actually that's the, okay, the same BGP. I will not repeat here. Everybody knows in this group. Next slide, please. So basically, we require IANA allocate the numbers to identify this attribute. Next slide, please. So probably, I don't know if you are interested or this working group interested in this, and if so, then we can move forward. Thank you very much. Any questions?
There are two questions. Guozhen Dong, you have first.
Yeah. My name is Guozhen Dong, come from China Telecom. I'm the co-author of this draft and welcome your comments and suggestions. Thank you. Thank you, Professor Lee. Thank
Yeah.
you.
And my, one second, please. So my comment, okay, you could go back to the embedded path attribute, please. So this is more clear in your internet draft than the presentation here, but you have, as part of your encoding, not only information for doing the mapping, but also carrying some portion of the BGP path attributes with the message. And similar to the presentation we just had about BGP to IGP and losing information, we know BGP to BGP, if we're not careful, losing information is also challenging. Are you aware of RFC 6368? Okay. Okay, so I'll paste this to chat. That is a feature for carrying a full set of tunneled path attributes for IBGP purposes. What I would request is examine that RFC and see if for the BGP specific portion of this, that's maybe a better way to carry the information, and then supplement it with the new information that you have specifically for the tunnels.
Okay, thank you. Okay, thank you very much.
No further questions. Thank you. This brings us to our last presentation for the day.
Hi, this is Gian. Can you hear me?
We can hear you.
Okay. Hi, my name is Gian Mishra. I'm with Verizon, and I'm presenting this draft of connecting IPv4 islands over an IPv6 core on behalf of co-authors. Next slide. So the motivation for this draft is, so currently an IETF standard exists for 6PE, RFC 4798. However, a draft or specification does not exist today for connecting IPv4 islands over an IPv6 core. So this draft fills that gap. So as an operator, as operators migrate to a from an IPv6 core towards an IPv6 core, draft will come connectivity for customers with IPv4 islands, customer connectivity over a IPv6 only core. The term 6PE is defined for labeling IPv6 packets over an IPv4. 4PE IPv4 packets over an IPv6 core. Next slide. So recap.
Gian, we have lost audio.
Oh gosh. Can you hear me now?
We can hear you again.
Okay, thank you. Okay. Components to 4PE. The first one is signaling the topmost label for the transport. So using RFC 8950 for IPv4 NLRI, or 32. Third, reconnecting audio, gosh. Can you hear me now? Looks like my audio broke up again.
It did drop again. We can hear you once more.
Okay, so where I left off was so the third component is the ingress and egress PEs must bind a label for all the IPv4 prefixes, BGPLU, RFC 8277, creating a two-level label stack. So all the customer V4 PEs. And then lastly, the 4P design supports MPLS. Slide. And we had a lot of good feedback, and I've incorporated most of the updates into the draft. So when RFC Net 7948 was written, segment routing did not exist. So with this draft, what I've incorporated into the draft is the inner working or operation of how 4PE would work with SRMPLS and SRv6 and any caveats that exist. So with that, I have cleared up some of the text just to make that more clear on the operation. I also had during the discussions on the mailing list, I had some really good feedback from Robert Rizik, which was really good related to our RFC 8950 next hop encoding and that and hits its relationship to 4PE and the reasons why we need a standard for 4PE for inter-vendor interoperability of connecting IPv4 islands over an IPv6 core, as well as I did spell out and acknowledge that there are other options available that are more transition technology type that are in the 6-man working group, and I've added some comments into the draft as related to that. However, this draft, the key goal of this draft is a BGP solution, and that's why we're here in IDR discussing this draft. And the second to last bullet here, we had an extensive discussion related to BGPLU and labeling the IPv4 prefixes that are tunneled over the IPv6 core. And so there's really three, and there may be more, but there's three really main reasons why the prefixes, so those v4 prefixes need to be labeled. So the first one is that if on the PHP node, if PHP default is enabled on that hop, and the transport label is popped, the native IPv4 packet is exposed, and if the core is in generally most operators have a single protocol core and they're not running dual stack, so it would be an IPv6 core, that IPv4 packet would be dropped. The second issue with having just a native IPv6 packet is that explicit null signaling pipe mode, so RFC 3270, MPLS QoS, and then RFC 4182 talks through the issue related to having a native IPv6 packet. So native IPv6 service label when using explicit null signaling, and which is not supported, is not allowed. So that's the second item. And then the third one is related to explicit null signaling, and just using the use of explicit null signaling label, just that label or any other label to signify the protocol type. And that's something that's important. So there are reasons why and that's something that I'm still working on updating the verbiage related to that in the draft. And the last, if I'd love to get any more comments and feedback on the draft. And after this week's IETF, I'll post some discussion topics to the mailing list. And after we go through another round of discussions, I think we'll be ready for our work group adoption. Next slide. So, and that's it. So once we go through another round of discussions on the mailing list, I think we can get the draft cleaned up and ready for adoption. Thank you.
Hey, Gyan, just a quick note. This is an IDR working group. I'm sure you know that.
Yes.
So are there any questions for Gyan for the presentation? We do seem to have one question. It will take him a moment. This is Stefan, who has engaged in aggressive sports and is taking a while to get to the microphone.
I'm here. Are you able to hear me?
Yes.
Stefan?
Stefan Nitkowski, Cisco, sorry. Quick question. I'm wondering, first of all, if we really need a draft for that, because it's just technology building blocks that are already defined. We could have a draft just to, I would say, highlight the architecture, but for me, it's more a network architecture design. So why not having a draft, but it's more informational, I would say, because we are not defining anything new. And as part of a draft, you are also going beyond just BGP stuff. You are talking about some data planes and so on. So I even don't know if IDR is the right place to do that.
Okay. Thank you.
And I think we'll be having exactly this conversation, with the best chairs as well.
Thank you.
Ben. One more question from Ben.
Hi, Ben Madison from Work Online. Just to answer Stefan's point, we run 6P today in production, and we have had to work with enough vendors who have made enough bizarre implementation choices for 6P in order to overcome interop issues that I think writing this stuff down for 4P is probably not a bad idea. Whether it ends up being informational and where it lives, I'm kind of agnostic to, but I think writing it down and having a record of it is a good idea.
Thank you.
Okay, there are no further questions in the room. Thank you for the presentation again.
Thank you.
So a couple of final parting notes. Again, we have a virtual interim on April 24th, and we're looking forward to seeing you there for the topics that are going to be covered. It should be very interesting. And a final request for you before you walk out of the room. As you can see, there are quite many of you. We have a room that is this large, partially courtesy of you signing in for the online virtual blue sheets. So if you have not scanned the QR code before you leave, please do so that we can make sure that we get a room big enough for us next time. That said, Sue, do you have any final comments?
None. Thank you.
Here.
See you all at next interim.
Have a good lunch.